Hello guys, I hope you all are doing good. So today here I'm going to make a video and that is not related to Django, but that is we are not creating any project in Django, but it's a simple thing that is a linked list and which is a part of data structure as you all know. So I am going here to show only the insertion part in linked list. That is, I will insert a node at the beginning of the list, at the end of the list, and at any position in between the list. So first let me open my file explorer. So I have created one Python file and this is totally empty. I will open it with my VS Code. Okay. So before writing the code, let me first tell you what is the difference between array list and linked list. Because we know array list is also dynamic. We have to understand by ourselves that when we have to use array list and when we have to use linked list. Because this will help us to have an optimized solution. Let me first open. I hope you're able to see this page. When we have to do any operation, that is, when we have to insert a element in the list, then we will go for linked list because it takes time complexity of big of 1. That is, it takes constant time. And whenever we have to go for search, that is, whenever we have to search a element in a list, then we will go for array list. Clear? So this we have to have analysis by ourselves for which problem we will go for which list. In linked list we have a variable size, that is a dynamic, and it's a non-contiguous memory, that is the nodes are connected by its address, and it's take insertion of time complexity big of 1 and search element in the list it takes big of n. So here is like this is the linked list. This is a node. Okay, this represents a node and node contains two part, that is the data part and the address part. Address of whose address? That is the next node it will get connected. That address is stored here in this next part. Okay. Let me show you. This is like this way. You can see here. Okay, so you see that is this is a node, this is another. These nodes are connected like a chain one, right? So this first node is the head node. It is containing the data 1, and this next part is holding the address of the second node. Second node address is 20. Similarly, this is the second node having data 2, and this next node is holding the address of this third node, that is the 40. This is the third node having data 3, and this is holding the address of its next node, that is this fourth one. This fourth node is having the data 4 and is holding the next, in the next part it is holding the address of its next node, that is the node to which it wants to get connected, that is this one. Since this node is having the address 50 and this fifth node is having the data 5 and the next is null because there are no further nodes in the linked list. So now let me code the logic. So for that, first I have to create a class node. We know that this init is a constructor, and this constructor will always have the self variable and the data, that is the data the user wants to give to be stored in the node. What we are doing inside the class node, we are just creating the node. Here self dot data will have the data, and self dot next will have none, because now it is not connected to anywhere. Let me write the comment, that is insertion at beginning in linked list. Def. Now I will write the insertion function. Insert at begin self data. New node, that is I am creating the new node which will contain the node data. And what is this node? This node is the node which I have created here. So that data will be stored in the new node. Then I will check whether my list is empty or not. So for that, we know the first node refers head refers to the first node. So I will check whether the head is none. If it's none, then the list is empty. So the node which the user is giving, that will be the first node and the last node in the list. If it's empty, then what I will do? I will make the new node point to the head. That is, head will point to the new node. Since the node is, that is the linked list is empty, so the new node which I have created, which is having the data as I have given in line number 8, that node will be pointed by the head. Okay, sorry. Then I will go for return. Else new node dot next equals to self dot head. If the list is, sorry, where it came, if the linked list is not empty, that is, if this if condition is false, then it will come to this else part, and it what it will do, so already one node is present, so the head which is pointing to the first node, now it will point to the new dot next part. That is, we know a node contains a data part and next part. So the head will now point to the next part. That is, it will point to the address of the new node. And self.head will have the new node. So let me show you one thing, the image, then it will be much more clear to you. You see, first my node was, suppose the if part is false. That is, there is node in the list. So this is the node in the list. Now I want to place this 1 in front of this 2. So 1, this is the data, and in this next part contains null. So what it will do? The head will now point to this 1. So that is the thing we are doing here. That is the new dot. This is the new node. This new node next part will hold the data of this head 1. That is, head is pointing to this node. This node address part will now be stored in the next part of this new node. And then when this is pointing, then what we will do? We will update the head to the new node, and then we will update this head to the new node. That is, head will now have the address of this second node, and head will point to the new node. This is the things we are doing in these two lines. That is, first the head value is containing in the next part of the new node, and the head is now pointing to the new node. So this is the insertion at the beginning in the link. Next, I will show you, that is, what to do for insertion in the middle, that is at whatever position in between the linked list. So here we are going to make, that is, insertion a node at a specific position in a linked list. Insert a node at a specific position in a linked list. So first we will write the function. So you can give any name to the function, but make sure that the name to be much more prominent according to the type of function you are going to write. Insert at index. It will contain the self variable, the data, and the index. Then I will check whether my index is equals to 0. If it's so, then I will call the insert at begin function, because there is no node in the list as the index points to 0. So I will call insert at begin function, and while calling I will pass the data. That is what data the user want to put in the linked list. So it will call this function, and this function will be executed. And then our return from the, okay. So why we are using this return statement? Because it will ensure that the function exists after inserting at the beginning. That is, upon inserting at the beginning, since there are no node in the list, it will call this function. It will insert, it will execute the logic, and then it will just come out from the function. Now we will write position equals to 0. We are declaring one variable, that is position, to be 0. And then we are writing current node equals to self dot head while current node not equals to none and position less than index minus 1, then position plus equals to 1. We are incrementing the position. Current node equals to current node dot next. If so, what we are doing, that is, here, suppose this if block is not executed, then it will come here. If we are declaring one position variable to be 0, and the current node is a node which will traverse through the linked list. First, it is pointing to the head. That is, it is point, since head we know pointing to the first node. So we are here taking the head inside the current node. That is, the current node is also pointing to the head, and head is also pointing to the first node. Then inside this while loop, we are checking that the current node is not equals to none and position is less than index minus 1. That is, we are checking that it means that this loop moves through the list until we reach the position just before the specified index where we want to insert the new node. That is, let me show you this with the help of this image. That is, suppose I want to insert this node having the data 3 and address 40 after the first index and before the second index. That is, I want, after inserting the node, it will look like this. That is, the index is holding, we know the index starts from 0. So this is 0, this is 1, this is second, and this is third. So I want to insert 3, that is this 3 data at index 2, that is before this 2. First, the current node is pointing to this, then it will come here, okay, and it will simultaneously check that the current node is also not none. That is, it means it ensures that we haven't reached the end of the list. If current node after traversing through the list comes to the end, then it's pointing to this none. And if it points to none, before we are reaching to that index, we have to insert the node. Suppose that index is not there and we have reached the end of the list, then it will show that its index is out of bound. That is, that index doesn't exist. Suppose a user want to insert a node after this third index and the current node has come to this, after traversing through the whole linked list, it has come to this node, and now current node is now pointing to this none. And if the node is, that is, this condition is getting satisfied, that is current node not equals to none, no, it's false, since the current node has traversed through the whole node and has come to the last node and is now pointing to the last node, and this last node is having none, so current node next is also pointing to this none, and we have came through the last, and now we will give an error, that is index is out of bound. So that's why we're making sure that current node is not none, and also we are making sure, that is, the position should be less than index minus 1. You see, we are giving two conditions, that is current node not equals to none and position less than index minus 1. Because this part will ensure that whenever we have reached, that is whenever the position has reached to that particular index, then it will stop and then it will insert the new node, that is it will insert the node at that particular index. So let me show you that first the current node is this. Okay, and position is 0. Now we are traversing. Now the current nodes come here and position is also getting incremented. You see, we have done position plus equals to 1. And how you are traversing the current node? By giving current node dot next to its current node. That is, the address will store in the current node. And this way the current node will traverse through the whole linked list. So here the current node is this. Then it will come to here. Now the position will get incremented by 1. Now the, the position will be 0. First we have initialized the position as 0. So 0 plus 1, it will be 1. So my position variable is here and my current node is also here. Okay. The user wants to insert here, that is in between this index 1 and 2. Now my index is 1. Now it will check position is less than index minus 1. That is, position is 1 and index is also 1. So 1 minus 1 is 0. Right? 1 minus 1 is 0. So here it will stop and then it will insert the node here. Because the condition is false. 1 is not less than 0. So here the for loop stops and I will insert the node here. For that, how we will insert the node? For that, we will write current node is not none, new node equals to node data, new node dot next equals to current node dot next, current node dot next equals to new node, else print index not present. So what we are doing here? We are checking that if the current node is not none, that is we have successfully found the index minus 1 node, that is we are found this index position, that is index is there, index exists, that is index is not out of bound. Now we will create a new node with the data. So we are creating a new node with the data by calling the class node, and we are setting the new node dot next to the current node dot next. So what we are doing here? Okay, let me. So we are setting the new node dot next equals to current node dot next. That is, let me show you this with this picture. The current node is holding, that is current node dot next is holding 30. This 30 will now be whole by this new node dot next, because the new node will be inserting in between this second, and this fourth data. So new node not next will hold the current dot next value, and current node dot next, as it was pointing to this 30, so now it will hold the new node data, that is new node having the address 40. This way we change the linked list. So that's the thing we did, that is the current node dot next value is holding in new node dot next, and new node value is holding in current node dot next, or else if that is index is not present. So this is, we are inserting a node at a specific position in linked list. Next we will do, that is insertion at the end of the linked list. So here we will show now, that is insertion at the end of the list. Def insert at end self comma data, new node equals to node data. If self dot head is none, self dot head equals to new node. Return current equals to self dot head, while current node dot next current node equals to current node dot next. Current node dot next equals to new node. Okay. So what we are doing inside this insert at function, we are taking the data, that is the data of the node which will be inserted at the end of linked list. And here in the class variable, we are using the class, we are passing the data, and we are taking the data in this node, and we are checking whether the linked list is empty or not. If the self dot head is none, that is it, if condition is true, then what it will do, that is the list is empty, then the new node data will be inside the head, that is head is pointing to the new node, and that is the first and the last node. Then we will return from the function, or we are taking one current node which will point to the head, that is head is point, that is there is node in the linked list, this line number 41. What we are doing, that is already there, this if condition is not true, so it's coming here, and already there are node in the list, and head is pointing to the first node, and the current node is also pointing to the first node, as we are initializing self dot head with the current node. Now we are using one while loop, and this while loop will check, that is current node dot next is not none, that is it is the current node is traversing through the whole linked list. And how it is traversing? By this line, that is current node dot next value is getting initialized in the current node, and when it is going to the last, that is when it is the current node is going to the end of the node, then here there is a, okay, here is one error. This will be outside of the loop, because while loop is used for making the current node to go to at the end of the linked list. So when the current node is none, that is current node dot next is none, then it will come out of the while loop. Now the current node is pointing to the last node, and at the last node we will insert the new node. That is, the last node will be the second last node. So now the new node is just coming to the current dot current node dot next part. That is, now the current node dot next will hold the new node. Before it was none, but after coming out of the while loop, it will insert the new node address, and new node will be the last node. So this is the whole logic. And now we will, okay, sorry, it's not one, this is LL. So here we are just calling the linked list. How we are calling the linked list? Because here I have made one class linked list, and I have inside that given the head attribute to none. So this is insert at begin. We are calling insert at begin function, and we are putting the data 3. Then we are calling insert at index. We are passing 5 data at index 1. That is, index 0 will have 3, index 1 will have 5, and index 2 will have 10, and the index at end will have 6. And then we are printing the list. Okay. So now let's run the save the program and then run. Sorry, I have to click save. Linked list object has no attribute print list. Okay. So let me just see the problem once more. Okay, so I have not written the print list function, but I have called the print list. Okay, let me write the print list function too. Div print list self current equals to self dot head while current print current dot data comma end equals to. So what we are doing, that is, after printing the each data, so here we are just having the current which is pointing to the head node, and while current is not none, that is, we want to traverse through the whole linked list as we want to print the data. So you're using the print statement, and you are just printing the data of the current node. Okay, let me write here node current node, then it will be much more appropriate name. So current node data it will print, and after printing, then at the end it will give this arrow symbol, and the current node will it pass, sorry, will it traverse as this, as we have seen in the previous function 2, how the current nodes are getting traversed. And while coming out of the while loop, that is when the current node has reached to the end of the linked list, that is when the current node is none, then at the end I will print none. So now let me run the code. Determine okay, I think something name it got. See, so first you can see that, okay, let me just clear the screen, and now let me run the code. So first I have called the function, uh, that is I've called the class linked list. So while upon calling the class linked list, the head attribute is initialized with none, and this class node is creating the data and the next variable. Data part will store the data and next part will store none. Then we are calling the insert at begin. This insert dot begin function will come here. Then it will execute its logic. So since there is no node, so first it is showing 3, and then index at insert at index function is called, and at 1 we are inserting 5. Again we have called at 2 we are inserting 10. Again we have called the insert at n function, that is this function, and it will keep the node at the end. And then when while printing the whole linked list, then while coming out of this while loop we are printing none. So let me show you uh, another way, that is L insert at begin. Suppose there is nodes in the list. Now there are nodes in the list, but while I was executing this line number 56, at that time the list was empty. So now I want to insert 13 in front of 3, that is at the beginning of the list. This will be L, and now I will call the print list function, so that to make sure that whether it got inserted or not. Now I will run the code. You see 13 got inserted at the beginning of the list. Now I want to insert 7 in between 3 and 5. That is 0th index, first index, and this is second index. So after index 1 I want to print, and before index 2. So for that I will, that is at which position I want to insert, at index 2 I want to insert 7. For that I will call insert at begin, sorry, at index. I will give the data, that is 7, and the index in which, at which I want to insert 7, that is index 2. Now I will hit okay. I want to see whether it got inserted or not. For that I will call the function, that is print list. Now I will run the program. You see at index 2 my 7 got inserted. Now I want to insert at end. What I want to insert at the end, suppose 80, and I want to see whether it got inserted or not. For that I will run the loop. You see here 80 got inserted at the end of the linked list. That is, this last node became the second last node. So this is the whole logic of insertion is going in the linked list. I hope you understood, and if there any doubt, you feel free to ask me in the comment section, and stay tuned to my next video. I hope you are having a great day today. Bye bye.